This is day 9 of Advent of Cyber 2023, and this challenge is called She Sells C# Shells by the C2shore. Having retrieved the deleted version of the malware that allows Tracy McGrady to control elves remotely, Forensic McBlue and his team have started investigating to stop the mind control incident. They are now planning to take revenge by analysing the C2's backend infrastructure based on the malware's source code. So, the learning objectives. In this task, we'll be focusing on the following vital learnings to assist Forensic McBlue in analysing the retrieved malware sample. The foundations of analysing malware sample safely, the fundamentals of .NET binaries, the DNSpy tool for decompiling malware samples written in .NET, and building an essential methodology for analysing malware source code. So, warning, handling a malware sample is dangerous. Always take precautions during analysis. As mentioned, handling malware is dangerous because it is software explicitly designed to cause harm, steal information, or compromise the security and functionality of computer systems. Given this, we will again introduce the concept of malware sandboxing. A sandbox is like a pretend computer set up that acts like a real one. It's a safe place for experts to test malware and see how it behaves without any danger. Having a sandbox environment is essential when conducting malware analysis because it stops experts from running malware on their actual work computers, which could be risky and harmful. A typical environment setup of a malware sandbox contains the following. Network controls. Sandboxes often have network controls to limit and monitor the network traffic the malware generates. This also prevents the propagation of malware in any other assets. Virtualization. Many sandboxes use technologies like VMware, VirtualBox, or Hyper-V to run the malware in a controlled, isolated environment. This allows for easy snapshots, resets, and disposal after the analysis. Monitoring and logging. Sandboxes record detailed logs of the malware's activities, including system interactions, network traffic, and file modification. These logs are invaluable for analysing and understanding the malware's behaviour. So for this task, there is a VM that we need to start, which is right there. The virtual machine can be opened in split screen, or you can use the RDP to access it. So optionally, from the day 8 virtual machine, you could use this password to unlock the zip archive Juicy Tomatoy to access the malware sample for the decompilation exercise. However, in this virtual machine, there is the defanged malware sample in the artifacts folder on the desktop. Introduction to .NET compiled binaries. .NET binaries are compiled files containing code written in a language compatible with the .NET frameworks, such as C#, Visual Basic.NET, F#, or Managed C++. These binaries are executable files with the .exe extension, or dynamic linked libraries, DLLs, with the .dll extension. They can also be assemblies that contain multiple types and resources. Compared to other programming languages like C or C++, languages that use .NET such as C# don't directly translate the code into machine code after compilation. Instead, they use an intermediate language, IL, like a pseudocode, and translate it into native machine code during runtime via a common language runtime, CLR environment. This may be a bit overwhelming. In simple terms, it's only possible to analyze C or C++ compiled binaries by reading its assembly instructions. Meanwhile, a C# binary can be decompiled and its source code retrieved, since the intermediate language contains metadata that can be reconverted to its source code form. So, basic C# programming. Based on the elves' initial checks, it has been discovered that the retrieval malware is also in C#. So let's quickly discuss C#'s code syntax to analyze the sample effectively. So we'll look at the code snippets right here. So namespace, classes, functions, and variables. Okay, so for this section, let's use this code snippet. Got this code here. Namespaces are a container that organizes related code elements, such as classes, into a logical grouping. It helps prevent naming conflicts and provides structure to the code. In this example, the namespace demo only is the namespace that contains the basic programming class. Classes define the structure and behavior through functions and methods of the objects it contains. In this example, basic programming is a class that includes the main function and the show output function. Moreover, the main function is a program's entry point, where the program starts its execution. Functions. Functions are a reusable block of code that performs a specific task or action. In this example, the show output function takes a string through the text argument as an input and uses it on console.writeLine to print it as its output. Note that the show output function only receives one argument based on how it is written. Variables are a named storage location that can hold data such as numbers, integers, texts, or objects. In this example, the print is a variable that handles the true text hello world. So if we go back up to here, we've got the namespace, which is used to access the class basic programming. And then basic programming class allows you to create object instances, and inside those object instances you have two methods, one called main and one called show output. But in the case of this one, basic programming is a class that's used to execute the application, so it then checks for the main method, and this is the starting point of where the program actually runs. So when the program runs, you create a string variable called toPrint, which contains the string hello world. We then run the show output method, passing it the toString variable as an argument. which, and then if we look in here, we have the argument string text. So when this method runs here, the variable text will have the value that's inside toPrint, which is hello world. And then you go to here, console.writeLine text, or in other words, it's going to print out hello world to the console. So we have for loops. So a for loop is a control structure used to repeatedly execute a block of code a specified number of times. It typically consists of three main components: initialization, condition, and iteration. So for the following example, the initialization is that we have integer variable I, which is equal to the number 1. So the condition is that this will run while I is less than or equal to 5, and the iteration is I++. So every time this for loop runs, the I variable is going to increase by 1, and then will continue running while it is less than or equal to 5. So this would run 5 times. So go 1, 2, 3, 4, 5, and at the last of the 5th one, it'll go to 6. But then as it's no longer less than or equal to 5, it would then exit out of the for loop. So conditional statements. Conditional statements like if and else are control flow statements used for conditional code execution. They allow you to control which code block should be executed based on a specified condition. So if the number is greater than 5, we then print to the console if the number is greater than 5. And if this one isn't true, we then go to the else statement, which is basically if the number is less than or equal to 5, in this case, the number is less than or equal to 5, it gets printed out. Importing modules. C# uses the using directive to include namespaces and access classes and functions from external libraries. So in this example, using system. The code snippet above loads an external namespace called system. This means that this code can now use everything inside the system namespace. C2 primer. According to Forensic McBlue, the retrieved malware sample is presumed to be related to the organization's remote mind control over C2 incidents. So to build the right mindset in solving this case, let's look at the run-through below about malware with C2 capabilities. C2, or command and control, refers to a centralized system or infrastructure that malicious actors use to remotely manage and control compromised devices or systems. It serves as a channel through which attackers use commands to compromise entities, enabling them to carry out various activities such as data theft, surveillance, or further malware propagation. So the flow of this connection is: the user executes a malware, the malware connects to the C2 and asks for instructions, the C2 server then responds with the 7 instructions, the victim's machine executes instructions retrieved from a server, then the malware on the user system reports the output back to the C2 server, and the attacker can connect to the C2 server to issue commands to be executed on the victim's machines. Seeing C2 traffic means that malware has already been executed inside the victim machine, as detailed in the diagram above. In terms of cyber kill chain dangers, the attacker has successfully crafted and delivered the malware to the target and potentially moves laterally inside the network to achieve its objectives. To expound further, malware and C2 capabilities typically exhibits the following behavior. HTTP requests. C2 servers often communicate with compromised assets using HTTP requests. These requests can be used to send commands or receive data. Command execution. This behavior is the most common, allowing attackers to execute OS commands inside the machine. Sleep or delay. To evade detection and maintain stealth, threat actors typically instruct the running malware to enter sleep or delay for a specific period. During this time, the malware won't do anything. It will only connect back to the C2 server once the timer completes. So, decompiling malware samples to DNspy. Now that we've tackled the theoretical concepts to build our technical skills, let's start playing with fire malware. Since we already assumed that the malware samples is written in C#, we'll use DNspy to decompile the binary and reveal its source code. So DNspy is an open source .NET assembler, debugger, and editor. It is typically used for reverse engineering .NET applications and analyzing the code, and is primarily designed for examining and modifying .NET assemblies in a user-friendly, interactive way. It's also capable of modifying the retrieved source code, setting breakpoints, or running through the code one step at a time. So to proceed, we'll go into the virtual machine we started, but first we need to show split view so we can get into it. And what we'll do is we'll view it in full screen mode just so we can have a clearer view of everything. So as you can see on the desktop, we've got DNspy right here, which will open that up. So once the tool is open, we will load the malware sample by going File, Open on the top left of the application, and then we'll go to this PC desktop artifacts, and we'll open juicy tomatoy _defanged. So with this opened up, File, Open, then it was this PC desktop artifacts. And we'll need to change the file extension here to all files because it's been defanged, which means it has had its file extension removed so you don't accidentally execute it. So we've now got it opened up here. Once the malware sample is loaded, you'll have a view like the image below. The next step is to click the main string, which will take you to the entry point of the application. So if we go into here, entry point is juicy tomatoy program main, so we click that. It has decompiled the program and taken us to the namespace juicy toy, which has an internal class of program, and then private static void main is the entry point function. And then private static void main is the entry point function. So as discussed in the previous section, the main function in a class is the program's entry point. This means that once the application is executed, the lines of code inside that function will be run one step at a time until the end of the code block. However, we won't be dealing with this function yet, since reviewing it without understanding the other functions embedded in the malware can be confusing. So, understanding the malware functionalities. You might have been a little overwhelmed when you saw the main function, but don't worry, we'll discuss the other functions before building the malware execution pipeline. Focusing on the individual functions before dealing with the main function can be considered a modular approach. Doing this allows us to easily break down the malware's functionalities without getting bogged down with long code snippets. Moreover, it allows us to recognize some potential execution patterns that ease our overall understanding of the malware. To start with, view the list of functions inside the program class by clicking the highlighted section as shown in the image below. We can go through the file tree of this. So we've got juicy toy, then we have program. So we've got the program class, and then we have the functions inside of it. So there's decryptor, encryptor, execute command, getter, implant, main, post-it, sleeper. After clicking, you'll see the functions in the drop-down menu. Let's run through them individually to better understand each code's meaning. You can click on the items as we discussed them to compare the code in dnSpy. It's also advisable to read the .NET framework to learn more about the internal functions mentioned in the following sections. So, getter, based on the source code, the getter function uses web request class from the system.NET namespace and is initialized by the function's URL argument. The name is already a giveaway that the web request is being used to initiate a HTTP request to a remote URL. So post-it, like the getit function, the post-it function also uses the web request class. However, you might observe that it has configured more properties than the first one. The most notable is the method property, wherein the value is set to post. This means that the HTTP request made by the function is a post request, and it submits the second argument as post data. So if we go back to here, actually it might be quicker to just go through the functions in here. So if we go back and let's go to post it. Yep, so HTTP request, method, post, content type, form URL encoded. The content length is the bytes. So this is the length of this data, the bytes here. User agent is pretending to be a web browser. It then makes the request here. Okay, so sleeper. Sleeper function only contains a single line. According to the thread.sleep function, thread.sleep function accepts an integer as its argument and makes a program pause for milliseconds based on the value passed to it. So it looks like that. Int count, then the sleep for count. Execute command, given the namespace and class, system.diagnostics.process of the initialized process class. It seems this function is being used to spawn a process. According to its documentation, from the initialization of process start info properties, we can also see that the file is being executed as cmd.exe, and that the execute command's argument, command variable, is being passed as a process argument. In short, the code snippet results to cmd.exe/c command variable. So essentially, what this code is doing, it's opened up a command prompt, and then it's running a command, the string command, inside of command prompt. Another thing to note is that the window style property is set to process.windowStyle.hidden, which means when command prompt opens, it's not actually going to be visible to the user. So we've now got the encryptor. The giveaways in this function are the AES classes used in the middle of the code block. If you hover over the initialization of AES managed, it also shows the namespace system.security.cryptography, which somehow means that everything here is related to cryptography or encryption. Moreover, the encryptor function accepts an argument and encrypts it using the hard-coded key and IV values. Lastly, it encodes the encrypted bytes into base 64 using the convert to base 64 string function. Decryptor, the function is the opposite of the encryptor function, which expects a base 64 string, decodes it, and proceeds to decrypt the following plain string text. Then implant. Last function implant accepts a URL string as its argument, initiates an HTTP request to the URL argument, decodes it with base 64, also retrieves the app data path and attempts to write the contents of the base 64 decoded data into a file. Lastly, if the implanted file was written successfully, it returns its location, if not, it returns an empty string. So building the malware execution pipeline. Now that we have analyzed the other functions in the malware sample, we'll return to the main function to complete the malware's execution pipeline. So if we go to here and go to main, so it's got URL to, so string. So I've got McGreedy secret c2.thm. We are going to the tasks path, then we're going string to C. So it's program.postIt. It's got URL here, so that is McGreedy secret thm /reg. Then it passes into data where name equals host name. So that's inside of string 2. If we go back to post it, it makes the request of the machine and then returns any C2 response back to it. So string it is program get it using the reg location. So if the response is not empty, it goes through the data it's given and it checks for certain commands. So there's command sleep. So if A does not equal sleep, check C. If A does not equal shell, if A does not equal implant, or if A equals quit. So it's got several different commands they can do, and based on the command given, it will run something else in the else statement. So if the command is not implant, that means it wants to implant it. So program.implant stash McGreedy THM spy.kit.exe. So if it's not empty, then decrypts the data, gets the result from it, then posts the data to URL 3, which is results. So if the command is shell, the text that was in the request is going to be executed, then it's going to be encrypted, then that data is being posted to results string 4, which is this. Then if the command is sleep, the program is slept for whatever number was given in seconds. Okay, so it seems pretty straightforward how this program works. We could probably just go down to here. Okay, so we've already gone through instructions. We could probably just start on here now. So what HTTP user agent is being used? So we saw that, what was it? It was a post-it one, we could see it right here. So we will copy this and we'll paste it into here. Although I accidentally included the quote mark, so remove that. Submit. So what HTTP method is used to submit? You use post request to submit. So what key is used by the malware to encrypt or decrypt the C2 data? I don't think I saw that, so let's go to the encrypt function. So I got key size. Okay, I think this is the key right here. So got bytes, transform, AS managed. Let's see, where's transform used? Okay, yeah, this looks like it's the key. Can't hack this super secure C2 key. Yep. What is the first HTTP URL used by the malware? That would be, go back to main. So I've got to copy this first part here, and then it goes to the path. Is task the first one? Yeah, it uses tasks. Okay, that's not correct. What's the format? Okay, no, it's not tasks. I thought that was the first one it uses. Maybe it's specifically in here. Oh, reg is the first one that's used. /reg. Or reg, whatever it is. How many seconds is the hard-coded value for sleep? I don't think I saw a hard-coded value one. Well, let's take a look. Yeah, there's no hard-coded value. Is sleeper in here? Oh, okay, this is the hard-coded, so that's 15 seconds. So, or 15,000. Okay, 15. What is the C2 command the attacker uses to execute commands via cmd.exe? So that was shell. And what is the domain used by the malware to download another binary? We saw that before, stash.mcgreedy.thm. Stash.mcgreedy.thm. Alright, so that is the 9th day of Advent of Cyber 2023 completed. If you like this video, make sure to like and subscribe so you can watch me complete the rest of this year's challenges.